Hi there. I realized that I forgot to do just one problem yesterday that you'll need help with. They're an explanation so that you can do your homework, and that problem is on page 13 of your packet. So I'm just going to explain this problem so that you can go ahead and do your work. So it says prove or disprove that the point square root of 2 square root of 2 lies on the circle centered at the origin and containing the point 2, 0. So the first thing I'm going to do is label the information that I was given. So I have a point. I know that's a value of x and a value of y. The circle is centered at the origin. So that means I have 0, 0. And since it's the center, I know I have my value of h and my value of k. And it also contains the point x, y. So the circle centered at the origin contains the point 2, 0, and we're going to have to prove or disprove that square root of 2 square root of 2 is on the circle. So the first thing I want to do is come up with the equation of the circle. Remember, the equation of the circle, the standard form, x minus h squared plus y minus k squared equals my radius squared. So using the information that I have the center HK, I have a point XY. I'm going to substitute those into the equation to solve for my radius. So I have my value of x, which is 2, minus my value of h, which is 0, squared, plus my value of y, which is 0, minus my value of k, which is 0, squared, equals radius squared. I'm just using substitution. So 2 minus 0 is 2 squared, plus 0 minus 0 is 0 squared, equals r squared. So I get 4 plus 0, which is 4, equals r squared. And I know since I'm looking for r, I take the square root. If I do it to one side, I do it to the other. And so from here, I can tell that my radius is 2. So I can write the equation of the circle. Remember, I'm going to substitute back in. I have x minus my value of h, which is 0 squared, plus y minus my value of k, which is 0 squared, equals my radius of 2 squared. So let's clean it up. X squared plus y squared equals 4. Here's the equation of the circle. That's our starting point. And now I want to see, does the point square root of 2 square root of 2 make this equation true? That's how I'm going to tell if it's on the point or on the circle. Think about if we solved a linear equation. X plus 2 equals 5. And so I solve the equation and I get x equals 3. And we said, hey, how do I know if that solution is correct? And we use substitution. I just substituted the value back in, 3 plus 2, and I said, does that equal 5? And we said, yeah, look I get the same value on both sides. I know it's true. I know this is a solution. It makes it true. So yes, it's on this equation. We're going to do the same thing here. We said square root of 2 is a value of x, square root of 2 is a value of y, so I'm going to substitute them into the equation to see if they make it true. So I have the square root of 2 squared for my value of x, plus the square root of 2 squared for my value of y, and I'm going to ask, does that equal 4? Well, I know that taking the square root and squaring are opposites. They undo each other. So I'm going to get 2. You can plug it in your calculator. It'll come out. And again, square root of 2 squared is 2. So I add 2 plus 2 is 4. And indeed, this does equal 4. It's true. Since it's a true statement, that tells me that, yes, square root of 2 square root of 2 is on the circle x squared plus y squared equals 4. So we proved that the point square root of 2 square root of 2 does lie on the circle centered at the origin and containing the point 2, 0.